Hello and welcome to this AimHi Live, but this is not a normal AimHi Live, for this one is an AimHi duo. Here's Phil.
Hey guys.
So obviously you guys, all of you will know Phil from doing the English, and Phil came up with this amazing topic for today, which is, can bacteria write poems? And so Phil's gonna kind of steer most of this one. But before we get going, what do you guys think is the odd one out of these images? So Phil, what's going on in the picture in the top left?
Picture in the top left. I don't know if there's a delay here. I'm sorry if there is. Picture in the top left is, I don't know who that is, but I think it's, I don't know, a very handsome man holding a large fish, which he speared in Sydney Harbour. It's an Australian salmon. It's not actually a true salmon, but it's delicious.
What does it mean that it's not a true salmon?
It's not a true salmon. They called it they called it a salmon. The English called it a salmon when they came over and they discovered it in Australia, and they didn't know what to call it, and it looked like a salmon in other countries, but it's not genetically or in the same taxonomy as the salmon family.
Got it. Okay, fake salmon. Okay, so what we got here is a fake salmon, scorpion fish.
Mm-hmm.
This is an email subject line that I received in an email from Phil a few days ago. So this is another key part of the Never Doubt Me, of the Find the Odd One Out. Does anyone know what this bottom thing is? What's going on here? Okay, Jeff is saying Hercules, and Hercules is good. Phil, do you know what it is?
I don't know. Is it Atlas holding up the sky? Is something happening there?
It's not. It's Hercules. So this at the bottom is Hercules. These are the pillars of Hercules. So for those who don't know, the pillars of Hercules are like the entrance to the Mediterranean, Sea. Because obviously a lot of the old world used to be focused, or almost all the old world used to be focused around the Mediterranean Sea, going back thousands of years. And the entrance to the Mediterranean Sea was called the Pillars of Hercules, which was really just the mountains being really tall and it being a really narrow entrance to get in from the Atlantic. But nowadays you can go and see some actual pillars of Hercules. Everyone is in caps. Anyway, I want to get votes. What do people think is the odd one out? Do we think? Oh, sorry. Yeah, which was the odd one out? Is it number 1, Phil with a fish? Is it number 2, the scorpion fish? Number 3, Phil's subject line of his email saying "Never doubt me," or number 4, the Pillars of Hercules? What do people reckon? Oliver's saying maybe the "Never doubt me" is the one out because words.
Oh, Jeff is cooler. Thinks it's the Pillars of Hercules. It doesn't lie in the name. Oh.
Wait, I don't get it. Oh my god. Yeah. Not a true salmon. Scorpion fish is not a scorpion. That's such a good idea. Is that okay? 1, not even Hercules can stand up to the handsomeness in 1. Oh, Sean, you charmer. So the odd one out is, in fact, the 3 is not a picture, so that is kind of on. The odd one out is number 4. And it's number 4 because, well, Phil, do you want to say why?
Well, one, I think this has to do with me, and I've never heard of the Pillars of Hercules. But all of these 3 things, 1, 2, and 3, are concerned with fish. The other day, I said to Matthew Shribman in a AimHi teachers meeting, I said, "Oh, here's a fun fact for you, Matthew." I said, there are more separate species of fish in Sydney Harbour than all of the UK coastal waters combined. And to which Matthew said, "That's amazing. I'm going to steal that from you." And then he said, and he wrote it down in his notebook, and then he got angry at me and he said, "No, it's not true. How could it be true? I'm deleting it." And he crossed it out. Do you want to explain the rest, Matthew?
I'm sure the end of that was fabricated, but I don't have a very good memory, so maybe I was filled with rage. So Sydney Harbour has 596 species of fish, whereas UK coastal waters, what do you guys reckon? How many species do you reckon there are in UK coastal waters? And I'm only talking down to a depth of 200 meters, so it's also quite specific. Sean is saying 595. It's really not even that close a race.
Yes.
It's not even that close a race. The UK coastal waters have about 276 fish species, but to be fair, that is only going 200 meters deep. Now the Mediterranean, it's coming in a bit closer to Sydney Harbour. That has about 540 different species of fish. But the Mediterranean's huge, and the UK coastal waters are huge, and Sydney Harbour is tiny. How are there so many species of fish there? What's going on? Anyway, so we decided that before we got into Can Bacteria Write Poems, because we know that some people arrive late, and we wanted to, to fill the beginning with some fun stuff. Before we get into that, Phil and I are going to have a favourite body of water off. So we're going to talk about our favourite bodies of water and why each one is better than the other one. So Phil's favourite body of water is Sydney Harbour.
Sydney Harbour.
But you guys can continue to vote throughout which body of water you think is the best. And yeah, we'll we'll see who wins. So Phil, do you want to go first? You said you had some even more juice about Sydney Harbour.
Yeah, well, I thought what we could do is I could say a fact about Sydney Harbour, and then you could say a fact about your body of water. What is your body of water?
So my body of water is called Movile Cave in Romania.
Okay, great. I'm looking forward to this. And then in the chat, maybe you could vote on what your favourite fact is. Which fact will come up trumps? So this is my first fact on Sydney Harbour. Okay. There's so many to choose from, I don't know which one to go first. But the first fact that I'll go with is more rain on average falls on the whole of the Amazon every half an hour than is contained within all of Sydney Harbour. That's my first fact.
So Sydney Harbour is like the rain that falls on half of the Amazon. Wait, on the whole of the Amazon every half an hour?
Whole of the Amazon every half an hour.
Whoa. Okay, that's pretty good. Okay, I've got a fact. Movile Cave, it's in Romania. I'm done. Your fact. Anyway, I've got a better one. Movile Cave has been separated from the rest of the biosphere, so the rest of everything alive on the surface of the Earth. Movile Cave has been completely isolated from all of it for the last 5.5 million years. So, yeah, go on, Phil, you're up.
Well, there must be some pretty cool stuff in there. I can't wait for the next fact. That's a pretty good fact. What do you reckon, guys? Whose fact wins? Whose fact is best? Is that LDBR saying cave is the best fact? No, surely not.
Thanks,
surely not. Matt, all this love for Matt. Oh, okay. That's pretty good. All right, Matt, you win this first round. Second round, I'm going to have to up the ante. All right. All right, here we go. In the summer of 2008, there were 74,000 tons of fish caught recreationally, so just with a line. And that's just in one summer. That's the equivalent of 25,000, the weight of 25,000 African bull elephants.
25,000? Wow. So 74 million kilograms of fish.
Yep.
Wow. Okay, Movile Cave is not as full of life as Sydney Harbour, not by any stretch, but it does have 48 different species that live down there that we found so far. It's pretty difficult to go down there because it's really poisonous, so people go in this diving gear and they try not to stay there too long. But yeah, it's got 48 species down there, and 33 of them only live in Movile Cave, so nowhere else. So obviously some of the species kind of went down there and have continued to survive on the surface of the Earth for the last few millions of years, but there are 33 species that have evolved or got lost down there and have been unable to survive on the surface. 33 species that only survive inside the cave, and so they're completely unique to the planet, and they're really bizarre. There is I've forgotten the name of it, but basically how it works is all across the kind of surfaces, the walls and things, grows this like mat-like bacteria thing that eats sulfur, because down in the cave there's hardly any oxygen. So up here we've got like 20% oxygen, whereas down in the cave there's more like 7% oxygen. So there's really a small amount of oxygen, but it's full to the brim with loads of hot sulfur, and so everything uses sulfur instead of oxygen. It's all like sulfur-based life. And so yeah, you get these mats of bacteria that are feeding on the sulfur, and everything else just kind of wanders around. Usually with no, I don't think any of them have eyes because there's no light down there, and they just chew on these mats of sulfury, eggy like bacteria.
That's a pretty good fact. That's a very good fact. Okay. Look, there's so much love for the cave. It's in all caps, which I initiated and I'm regretting right now. Just cave. One more. How about just one more, really quick one? See if I can get one fact. And all right. So Sydney Harbour lies in an interesting part of the world. It gets tropical currents from the Great Barrier Reef, the East Australian current, which you might have seen in Finding Nemo, where Nemo's dad hitches a ride in that vortex with the sea turtles, and it gets that. So it brings down tropical species, but it also brings up temperate and even Antarctic species. All the way, you get leopard seals even occasionally in Sydney Harbour. But Sydney Harbour is one of the busiest harbours in the world. And up until 2003, it was crazy. In one of the busiest harbours in the world, there was still commercial fishing happening in Sydney Harbour, but they banned it. And then since then, so many sharks have moved into Sydney Harbour, and the big three most dangerous sharks are the great white shark, the tiger shark, and most dangerously of all, probably the bull shark, have moved into Sydney Harbour, that in summer, if you swim in Sydney Harbour anywhere, statistically, with the perception range of a bull shark, the volume of water, the amount of bull sharks in Sydney Harbour, there will be a bull shark larger than 1.8 meters that knows where you are. That's my fact.
Whoa, that's so cool. I've run out of facts about Mobile Cave. Well, I got some more, but I think we should move on. But that's so cool.
All right, we should move on.
And also,
that was
sharks.
Fun. I like that.
Don't be scared of sharks, y'all. I mean, obviously, sharks are scary in the sense that they're dangerous, but sharks are one of the best indicators of a healthy ecosystem. So you got to have a load of sharks, and that's why it's great that Sydney's banned commercial fishing in the harbour. Anyway, cool. Okay, right. Should we go into this talking about poems?
We should. Let's crack on. Okay.
Begins with this guy, right?
So yeah, this guy here. I introduced you to this guy recently. This poet, Christian Book, who's a Canadian poet.
I need to get the book. It's next door. Wait, you tell them. I'll run and get the book.
Oh yeah, go. So Christian Book is a special type of poet. He's experimental poet. So he's not concerned with the content of what he's writing. He just wants to kind of play and muck about with form and how words go together. So he wrote this whole book. It was called Eunoia, and Eunoia is essentially it's just 5 sections, and each section, every single word in that section is written with only words that contain A, and then the next one is E, and the next one is I, and the next one is O, and then U. And so he coined it this word because it's the shortest word that he could come up with that had all 5 vowels in it. And he wanted to explore what was the personality of E, personality of O, of I, of A. And you've got that book there, Matthew?
Actually, I left it down at my flat in London.
Oh, don't worry about it.
So, but
okay.
Go on, keep talking about it. It's so cool.
He's so cool. So in the book, like you just kind of discover he doesn't really care so much, even if the poems fully make sense. What he's concerned about is sound and the personality of the words themselves. And his latest experiment in poetry is what he calls the xenotext. And essentially, he wanted to make a poem that would live in the cell of a bacterium. And it's kind of pretty crazy and pretty cool. We're going to just sort of go into it. Essentially, what he did was he realized, like, if I'm going to do that, I need to kind of write a poem and code it with DNA. So maybe, yeah, let's go straight to the poem.
Let's do it.
Yeah. Okay. Oh, I just got a question. What does eunoia mean? I don't know. I couldn't Google that very quickly, but I think I remember it means like good sound. EU means good in Greek.
Google it. I want to know as well. But it feels right. Like you should read some of the samples of the poems. Like it's amazing the different character that they have. Like the O's are obviously like very kind of soothing and calming, and then I think it's the E's that feel like the rhymes are really easy, and they're really easy to like to begin with. But then as time goes on and you're reading more of them, they start to feel a little bit like, is it E that happens with, or is it I? I can't remember.
I found I oddly aggressive.
Maybe it's that one. Yeah.
Yeah. You know, it means a well mind or beautiful thinking. And the way that Christian Book decided that he would write his poem is it took him 4 years to write this poem. He wrote a poem, and each of the letters in the alphabet had to correspond with another letter. I don't fully know the science of this, but the first poem, I'm just going to read to you guys now. Any style of life is prim. Oh, stay my lyre. With wily ploys, moan the riff of any tune aloud. Moan now my fate, in fate we rely. My myth now is the word of life. So that was his poem that he wrote. And his poem that he wrote, he wanted to put that into DNA, but it wasn't just that part of the poem that he wanted. He wanted to store a poem in DNA, but he also wanted the bacterium to respond to that poem. So in order to do that, I don't know the science behind this. Matthew, you're drawing some squiggles on the screen. Perhaps you can help explain that.
Okay, so I was first going to talk about the kind of call and response. So some of you will have already studied this bit of genetics, and some of you will be yet to do this. So I'll just do a really quick summary of how DNA works. So DNA are the two strands that are inside the nuclei of all of our cells. So every single one of our cells contains all of the information to make the whole of us, and more information, loads of information that isn't even used. So think of every single cell in the body as containing a huge library, an enormous library of information. And now the library is all sorted into these like corridors that are essentially the strands of DNA. And every single strand has a strand that goes with it, a pairing strand. And so we're not going to get into too much... Matt's drawings are ASMR for the eyes. Thanks, Jeff. So yeah, we're not going to go too much into like what these strands are made of, but what I want to show you is that every strand is joined together by these things called bases, and the bases come as there are 4 options. So if you think about coding on a computer, computers are all coded in binary. Like the entire of everything you're seeing on a screen now, everything that you're receiving in terms of audio, all of it, it's all just a series of ones and zeros arriving down the internet and into your house and into your phone or computer or whatever you're watching on. It's all just 1100111100, like an incredibly rapid speed of ones and zeros flying past. Whereas human DNA doesn't use 2 things. It doesn't use 1 and 0. It uses 4. So it uses C is one of them, and G is another one. And then it also uses A, and it uses T. And the key idea is that these go in a pair. And I like to remember that the C and G go together because they're kind of curvy, and the A and T go together because they're kind of aggressive, spiky shapes. And that's how I've always remembered it. Anyway, so if you have a C here, and if you have a C here, for example, and if you've got another couple of C's down here, then those will all be paired up with a G. So every C pairs up with an opposite G, and every C pairs up with an opposite G, and then that's going to be the same here. Opposite those ones are these ones. So basically, DNA strands are normally zipped together, but this bit I've just unzipped so that I can show you what's inside. And then also you'll have anywhere where you've got an A, it will pair up with a T, and so on. And I'll just finish filling those in. So DNA all works symmetrically. Ooh, I missed one of those there. That one should be a dark blue. DNA all works symmetrically. So every time you have a C on one side, you'll get a G on the other side, and A on one side, you'll get T on the other side. So what Christian has done, this poet, is he's taken, I think he's taken a sequence of 3. So he's taken a sequence of 3, and he's decided that that is one letter. So if he decides that this is the letter A, then opposite it, this is what he is using to code for the letter T. So on one side he's using the alphabet, and on the other side he's using the xenocode. So he writes a poem down one side of the DNA strand using his alphabet and using the CGAT combination that he's decided for each letter. So for this one we decided that A was going to be CAG. That's the code that he's used. And then he's made sure that every single letter corresponds to another letter such that his poem has a symmetrical poem on the other side. So that's just one level of it, which is like baffling enough and completely genius. And no wonder it took him like years to work out how to do this. But the other thing is, the actual gene that he's created, so the gene is just the sequence of bases. The gene that he's created is not just a poem encoded. The gene actually makes proteins inside the bacteria. So Phil, do you want to talk about the proteins that it's making?
Yeah, so the gene that he injects into the DNA causes the bacterium, and initially he tested this out on E. coli. E. coli are famous for giving that bad smell in poo. E. coli, a very common bacterium, and the chemical effect was to make the E. coli glow pinky red. So when you read the poem, and the poem actually alludes to this pinky red glow. So if we go back to the poem and we read it, there's the opening line, and then there's the response on what the germs has. So it's any style of life is prim, the fairy is rosy of glow. So the fairy is rosy of glow is actually referring to the chemical effect that's happening in the bacterium itself. But maybe you can explain, Matt, how the response happens in this bacterium.
So the genius of this is that, like, it's not just us reading the poem. It's not just that we're reading any style of life is prim and then we're also reading the fairy is rosy of glow by following the code that's been laid down, but actually the bacteria itself is reading the poem. This is my DNA strand. I kind of want a bit more space, so I'm gonna go over here and move. I'll just do it down here. So when you've unzipped your DNA strand, remember DNA is this huge long sequence. It's your enormous library of all the information inside your body. So let's say that this is the bit of DNA that we've unzipped, and this is the gene for the poem. So what will happen is, and obviously the gene is on both sides, but the body will only actually read one side. So the body will read the side that we read on the left of the poem. So when I say body, I mean bacteria. The bacteria will read this side, and in doing so, it will collect together loads of these little floating bits of DNA, and it will rewrite the poem itself, but the opposites, well, the reflection of the poem, because for every time it has a C, it will connect with a G, every time it has an A, it will connect with a T, and so on. And it will basically make a little copy or a little recipe of this poem. Yeah, the body will take this little bit of copied DNA and send it to the factories, which are called ribosomes in the body, that will make proteins. So the protein making things inside the bacteria will then produce the protein which is coded for by the poem, which happens to be a fluorescent protein. Fluorescent means that it's kind of glowing, right? Now, quick thing before I hand back to Phil is that anything fluorescent in nature is poisonous. Don't eat fluorescent stuff in nature. It's always poisonous. There have been loads of chefs who have been thinking, oh, wouldn't it be cool if we could have a fluorescent dinner? No. All the fluorescent stuff is poisonous.
Initially, these were implanted into E. coli, but E. coli then started taking the poem and rearranging it and mutating it. And in a sense, Christian Book wanted to have a place that would store his poem permanently, but he didn't create the first bacteria that could then write a poem with its response. So for every letter, any style of life, the fairy is Rosie. If you look, A matches to T, and then N matches to H in the alphabet and in the xenocode. The germ, the bacterium, started to fully distort the text, and then it broke apart and started editing it and started making new poems all over the place, which is cool, but isn't what he was trying to do. So instead, he thought, all right, I'm not going to use this poo bacterium E. coli. I'm going to find a bacteria that will last. And I don't know much about these, but he used what's called an extremophile. Matthew, you know a bit about extremophiles, right?
So before we go on to extremophiles, does anyone know why E. coli was changing the poem? Does anyone know what E. coli was doing that was continually editing the poem? So Rebecca Khan was coming with tardigrades. Tardigrades are one of my favourite extremophiles. We'll talk about extremophiles in just a sec. But why would it happen that E. coli would edit the poem?
Rebecca just said it can adapt.
Yeah. Okay. Great.
Attached or mutating.
So brilliant.
All caps, please. Okay, Jeff, we can do all caps, but you need to stop doing your acrostic poems.
So yeah, it's all about adaptation. So most of life on Earth has evolved to allow things to adapt quite quickly. So we're good at maintaining the DNA inside our body, but we're also good at creating chaos within it. So if you try and it's the same goes for most bacteria. So if bacteria is coded to have a certain sequence of DNA, then whilst it will try to maintain that sequence, it will also copy random different versions of it. So DNA is made of sections, like long sections called this is going into quite advanced biology, so I'll skip over this quite quickly, but just to show people who are interested. DNA is made of long sections called exons and introns. And basically, the exons are the useful bit, the bit that we actually use to make stuff, and the introns are just kind of like spam in between. They're just like filled in space that seems to not do anything. And all living things are supposed to be experts at chopping out the introns and just using the exons to make the stuff that we actually want to make. However, when you have a bacteria that's trying to evolve and trying to adapt, it will randomly chop out exons by accident. So you'll basically get bits of the poem that will be removed and just thrown away. And then that might be more beneficial for the bacteria. And then the bacteria, because E. coli is like, maybe I don't like this poem, I think I can do it better. And so essentially it kind of cuts bits out and creates randomness in it so that it can evolve. Anyway, so let's go to extremophiles. Where did we have the picture of extremophiles? In fact, let's just stay here. What's this a picture of, Phil?
The blue one? The blue circle one?
Blue one, yeah.
That is a picture of an extremophile, and the extremophile that Christian Book implanted the gene into.
Amazing.
Deinococcus radiodurans. Yeah.
Okay, cool. So an extremophile, just to quickly re-summarize, although we were talking about them on one of my lives quite recently, is something that can survive in really extreme conditions, considering what there is on most of Earth. So on most of Earth, it's normally between about like minus 20 degrees and plus 30 or something. The extremophiles are things that will quite happily cope with 150 degrees or minus 200 degrees. They'll cope with the vacuum of space, which most life never has to cope with, and they'll cope with going without food or water and so on. Now, this extremophile, though, is very special in that it can not only cope with a lot of those things that I've just listed, but it can do one other thing that is extremely rare and has prompted a lot of scientists to think that maybe it comes from somewhere more mysterious than you might first think. Phil, do you
Aliens.
Want to take over?
This is the alien bacteria.
Sorry, Phil, do you want to talk about why he wanted to use this bacteria?
I believe he wanted to use this bacteria because he wanted stability. He wanted to create a poem that would be eternal. And even after the sun explodes, he wanted there to be a poem created by him existing in the universe. And to do that, he was thinking, well, metal would disintegrate, everything would go. but maybe there would be an extremophile that would still be replicating his little poem over and over in the vacuum of space.
Amyson was like, wow.
Do you have anything particularly about Dinococcus radiodurans, Matthew?
Yeah, sorry, I did prepare. I have looked at stuff on that. Sorry, I thought that you wanted to talk about it. Yeah, so Dinococcus radiodurans. So let's break apart the words, since this is that half English, half science. So Dinococcus. Ooh, does anyone know where that name comes from? I'm so bad at spelling things. Anyway, the root of the word is that it is dinosaur chickens. Exactly.
Dinosaur chickens.
Yeah. No, the root of the word is terrible berry. Terrible. I don't know why. I think it's to do with the glow that it can produce. But it also could be terrible grain. Anyway, that's not the important bit. The important bit is the word that goes after. So it's Dinococcus and then radiodurus. So radiodurus is durable with radiation. So if you expose this bacteria to extreme levels of radiation, someone was talking about tardigrades able to survive nuclear bombs. That's true that some tardigrades can survive nuclear bombs. But this bacteria, above and beyond all bacteria in the world that we've ever discovered anything about, which is why people are theorizing about it potentially coming from a different planet. Although I personally I'm really skeptical about that. But it is cool, the idea that it could have come from there. And the reason I think it is because why would something have evolved to be so durable to radiation? Like, you can shine the most intense gamma radiation on this bacteria and it will still then reproduce and conquer food or whatever it is that you give it. So they've done experiments where they show that food is still spoiling even when it's been exposed to like the most intense gamma radiation blasts that should kill all life. And yet this survives because it has evolved to completely protect its DNA. So whereas, the radiation blasts destroy DNA, and that's why they destroy us, because our cells then can't produce the things they need to produce in order to stay alive. But Dinococcus radiodurans can not only protect its DNA really well, it can also repair it really well. So if it loses an entire half of its DNA, so if one of the halves gets entirely destroyed, and the remaining half has loads of gaps in it where there's information that seems to be missing, Dinococcus radiodurans can somehow reconstruct it and rebuild it and build it back into a double-stranded sequence again in ways that we're still baffled by, and we're looking into for ways that we can help ourselves to resist cancers and things like that, because this is essentially completely immune to, well, it's a bacteria, so it can't get cancer because that doesn't make sense. But if it were a larger living thing, it would presumably be immune to it because it's so good at protecting its DNA. But not just that, if you get two cells of Dinococcus radiodurans and you put them next to one another, then if one of them is more damaged than the other, they will literally feed DNA to one another, like between the cells, in order to repair one another. And so that's another way they can. So if you put a poem inside one of these, then it will continue spreading and spreading and spreading, and even if it's exposed to the radiation of the sun, it'll still be fine.
One thing that's truly amazing about this is that the content of the poem that Christian Book wrote mirrors this exact philosophy. He wrote this poem in a style that was kind of, it's actually a set style of poetry invented by the ancient Greeks. It's called Pastoral Poem. And a pastoral poem was normally a shepherd boy who saw a beautiful goddess or some nymphs and then went, oh my goodness, you're so beautiful, I want to be with you. And so the first half of the poem, he calls it Orpheus, the music player from ancient Greece. And it's sort of praising life and saying, I'm gonna play on my lyre, I'm gonna play on my instrument, I'm gonna celebrate life, and I'm gonna moan for it, I'm gonna like yearn for it. And then the reply is almost like the germ reply, but the goddess reply is like, oh, stay my lyre, like just settle down, like it's almost like a bit of a cold kind of a little bit of a rejection there. We wean him of any milk, like it's just a bit of a like ease up, champ. I know you're trying, but don't come near me. So moan more grief with any loss. Like don't sort of try to praise me. Instead, this is sort of like a bit of a lament. And so arguably this last poem that's going to exist, maybe when all of us are gone, the sun is gone, encased in this extremophiles protected DNA and then spreading and repairing throughout the cosmos, is humanity's reaching for something more, and then maybe realizing the cold, hard realities of the vacuum of space. It's a pretty sobering thought. Yeah.
I love how it flips as well. The call and response is so cool. I kind of want you to sit and talk me through even more of this, Bill. This is it's such a good idea. I like, to be honest, everyone. Like, I've been reading this as we've been on the live, because I was planning the other lesson that I did before, the other live, and so for me this is like the first time like properly engaging with this. And someone was right. Someone said about him having quite a large ego, and I guess in some ways you could say that's true, because you want something to last forever. But it seems more like he wants it to last forever because it's still like it's a beautiful encoded message that even if there's no one around to understand what it means, it's still meaningful, which I think is really powerful.
I mean, from a technical standpoint, this poem is so hard to write. It would be so hard to write. It took him 4 years to get the coding right, but then to create any meaning out of it, I think is phenomenal. We could go in and analyze it, like you've highlighted the flipping of in fate we rely, but then changing the meaning of it. So at the start, it's in fate we rely, which is like it's almost like a call to, like I want this thing. In fate we rely. I want to sort of like affirm life, and I want to with wily ploys moan the riff. I want to like celebrate it, because any style of life is prim or good, any style of life. And then with this one, it's in fate we rely, mourn more grief with any loss. It's kind of like it's like a backhander. It's almost like a rejection, using the exact same phrase that the first poem used.
I love how,
I don't know. I love it.
I love how this feels like a momentous goodbye, like of the word of life, as in like the end of humans and of all other life on Earth, if it were to last that long. But then this is just like whatever's, any milk is rosy, so it's not important to the universe. It's beautiful.
Yeah.
Go on.
And a way to close this is this project was originally inspired by a quote that Christian book liked from this author, William S. Burroughs, who famously said, "The world is now a virus." And with that last line, the word of life, the world, and the world, or the human world and everything we know it, in a sense, is not a virus, it's part of a bacterium. But yeah, that's what his aim was for this. And I don't know, I think it's beautiful.
Me too. I really enjoyed this. How do you guys, let us know what you think about these AimHi duos that we've started doing. It's great for me because I get to learn about more English and poetry and stuff, which I don't normally get time to do. And if you like this kind of format, we're going to keep doing it. So let us know. Bailey Tom loves the duos. By the way, I shall also bring up this. This is what's coming up next. But yeah, thanks so much everyone for coming along. Do follow the social media at AimHi Live, and do sign up to our mailing list on the website down below, which is kind of hidden inside that diagram of a molecule thing, but you can find it. We will be back. Thank you all.
Thank you guys. All right. See you later.